Alright, so next one is it says a scientist takes a random sample of 30 sun-like stars and finds that 10 of them have planets orbiting them. The scientist uses a computer to simulate selecting samples of 30 sun-like stars so that each star has about 1/3 a chance of having planets orbiting it. They find the proportion of stars in the trial that have planets and repeat the process to get 1,000 trials. The dot plot shows the proportion of stars that have planets of each of the 1,000 trials. And it looks as a bell shape, as you can see here. And it says the mean of the sample proportion is 0.33. And the standard deviation of the sample proportion is 0.086. Alright, so you have the mean of the sample proportion and you have the standard deviation of the sample. Remember that the minute it says proportion, they're talking about the margin of error. Okay? When you see that word in there, proportion, you know that this is talking about the margin of error. So, and as you can see here, if you can keep reading, that's what's going to show up. So, margin of error, should click if it says proportion. What estimate should scientists use for the proportion of sun-like stars to have planets orbiting them? Okay, so what proportion? They're telling you what proportion. The scientists should estimate a proportion of 0.33. That doesn't change. The mean doesn't change. Okay? What it changes in this problem is what's the margin of error. Remember, the margin of error is twice as much as the standard deviation. And I need you to understand what you're saying. I think so many people are finding this so complicated, and it's really not. Like, read what I have said in the vocabulary, watch the videos. If you're saying that the standard deviation is twice as much, I'm not really sure why you're now multiplying it times 2 if that's what it means. Whatever standard deviation is, you need to multiply times 2, and that's the margin of error. I'm honestly don't know how else to say that other than just being very specific. Standard deviation times 2, okay? So in this case, we can agree. Let me see if I can paste this. Okay. So here we have the scientist should estimate a proportion of 0.33 with a margin of error of, it says here that the standard deviation of the sample proportion is 0.086. So if you multiply 0.086 times 2, you're going to get 0.172. And that's your answer. There's really nothing else to do there. Okay, next one. 7. C is a circle with radius r. Which of the following is true? Select all that apply. So, let's see here which ones are true. Let's read A. The diameter of C is 2r. So, first of all, let's remind ourselves what is C. Okay? I mean, I don't know if we're gonna use this, but we can try. So the circumference is 2 pi r. Okay? But we can also say that the diameter is, instead of writing 2r, we can also say the diameter times pi, because the diameter is twice the radius. So, with that in mind, we can start answering this. Well, I guess I can just circle this instead of writing the answer. Let me just erase this. Okay, so A, The diameter of C is 2r. Yeah, it's true. That's the diameter. We just said that. So A is true. The circumference of C is pi r. No, that's not the circumference, right? Like the circumference is 2 pi r. So B is not right. C, the circumference of C is 2 pi r. Yeah, that's correct. 1/4 of the circle has a length of pi r over 4. No, because if you put a 4 under here, like if you say 2 pi r over 1/4, this will be at 1 and this will be at 2, so that's not true. So this is not true. 1/4 of the circle has length pi r over 2. Yes, that's true. So there you go. Nothing else to do there. Okay, determine the radian measure of an angle that measures 225 degrees. Okay, so you gotta remember that the formula here is another thing that I've noticed as I was looking at your exit tickets and some of the conversations I had with some people. It seems that there is a misconception on how to do conversions from like one unit to another. So if you don't understand what they're asking you, you won't be able to do the problem. What does it mean when I say determine the radian measure? Like that statement, you need to translate it into simple words. Okay, so let's put it this way. Let's see. I'm pretty sure you have gone to the doctor, right? You have gone to the doctor. Just to give you an example. When I go to the doctor to see my baby, I have to weigh in every time I go there. But for some reason at Kaiser, I have Kaiser as my medical insurance. And every time I go there and I weigh myself, they have the scale set in kilograms. Okay? But the English system that we have here in the United States, we use pounds and then we use inches, feet and inches, okay, to measure our height and our weight. So when I go there, I know how to convert it in my head. So when they tell me the weight in kilograms, I already know how to convert it. I just need to multiply times 2.24. So I have an idea of how much I weigh. So that's basically what they're telling you here. They're telling you we're giving you two different measures, okay? We're giving you radians and we're giving you degrees. So it says determine the radian measure. So that means that you need to convert these degrees to radians, okay? And I'm pretty sure that some of the nurses or whoever is weighing you in, they tell you, I will tell you your weight in pounds in a minute. Just let me input this in the computer. And then they tell you, so you weighed, I don't know, 140 pounds, right? But you see, when you see it in the scale, you see a small number because that's in kilograms. So that's exactly the same here. They're telling you to convert the kilograms to pounds, okay? In this case, they're telling you convert the radians to degrees. So in order to do that, okay, we need to say 225 degrees times, okay, pi, remember, radians, over 180 degrees. So here the degrees cancel out, okay? And then if you divide 225 over 180, let me tell you something. Let me be very clear about something, okay? I am not going to accept any answer that is not as a fraction. And I'm going to put that in there. So do not just use the calculator in the online and you tell me what's in decimals. I'm not going to accept any answer in decimals. Everything has to be in a fraction. So what I need you to do is that I need you to find what's the greatest common factor between the two numbers and then start dividing. Okay, if you say that 225 can be divided by 15 and 180 can also be divided by 15, then I need you to tell me as a fraction, not in decimals. Okay, so let's say 225, let's start with 15. So 225 divided by 15, that's 15. 180 divided by 15, that's 12. So 15 and 12, they still have common factors, so it's 3. So 15 divided by 3 is 5, and then the other one is 4. So 5 pi over 4 radians. So that's your answer. So basically you are taking this fraction and you are simplifying it to its lowest terms. Alright, then next one, it says make sure you write your answer using numbers. Okay, so determine the degrees. So in your answer, some of you, I noticed that you're able to put the pi. So if you're able to put the pi, just put the pi. If not, you can just say, oh man, I don't know, it's not going. Okay, if not, you can just say 5 pi over 4 radians, and I will accept that. Okay, either or is fine. Oh, I'm sorry, somebody's cutting the grass. Determine the degree measure of an angle that measures 9 pi over 5 radians. Alright, again, they're telling you to convert the degrees to radians. So what do? You use the other formula. Okay, so 9 pi over 5 times 180 degrees and then pi radians here. Okay, and remember this is radians as well. So the radians cancel out, the pi cancels out, and now you just have to multiply 9 times 180 divided by 5, and that will be 324 degrees, or 324 degrees, in case you're not able to find the degree. Okay, that's really it. There's nothing else. I might probably show you or ask you one more question regarding radians. So review the last lesson, because I will take one more question. I will not cover it. That question will be just, you know, I usually do that. Like, I don't give you exactly everything. Maybe just 1 or 2 questions won't be there. But there will be 10 questions in the exam, and one of them will be about the radians. So review the lesson, the last lesson, because I will take it from there. Okay? Let me know if you have any questions.